So like some of us, like, you know, who are new, didn't know that you are Dr. Kuldeep. So Dr. Kuldeep is from Diganta. He's come all the way from Rajasthan to attend this geography presentation. So we have quite a varied geographical, you know, places like from Pondicherry I can see, from Homi Baba, Bombay I can see, and like who else? Yeah, Vidya Bhavan. How can I? And yeah, and also the other resource person, Dr. Chandrasekhar Gauls, cultural geographer as well as the director of the Indian Institute of Geographical Studies. Mo was just sharing with me yesterday. With a short notice, he accepted, and he remarked saying, for geography, he will go anywhere. So it was very heartful to know that, sir. And like, yes, the speaker and my colleague, Mahuya has done her post-graduation in geography and worked as a teacher for the last 12 years before joining the foundation. And she's, if I could, like, you know, again dramatically add to, like in my own style, stylistic features, is this what you call? She has like actually traveled far and wide towards, like, you know, the below the equatorial region, Tropic of Capricorn in fact, like Australia, New Zealand, and above the equatorial region, and now near the equatorial region she lives. And like, yeah, over to you, Mahuya.
Thank you, Karpagam.
Yeah, one more announcements of that your break and all.
No, that I will do it. Why this introduction session yesterday it was not there. During breaks, many people actually ask for it. Like, you mentioned people, but we don't know really who are they. So, and they said even it's good if you can introduce the speaker. I thought since all the details are sent, it's not required. So that's how we started
today's thing.
Huh?
So
and,
no bias, guys, please.
And as I mentioned, from Vidya Bhavan we have Kamal Mahindra and Pushparaj. And two more, Devyani and Vandana from and Arindam from
Homi Baba.
And I think others you know. So we have members from Field Institute. And yesterday we had teachers also from schools like Valley School and from Shishu Mandir teachers were there. I don't know whether today.
Today Shishu Mandir
from Shishu Mandir. Welcome. And we have few students also who are attending the programs. So from our own university. So this is the kind of group that we had. Yeah, please.
Now, before I start my session, I would like to say a few words on the rationale behind why I chose this topic, that is looking at geography through a scientific lens. Now, the reason why I chose this topic is because of the challenges which I faced, both as a student as well as a teacher. Now, if you go back and see how the subject geography has evolved over the years, we will see that the scope of geography has widened. Initially, geography was only dealing with what and where. That is, questions like, what is the capital of India? Where is Bangalore situated? That is, it was in the knowing level of thinking. But today, if you look back and see how the scope has evolved, we'll see that it is much, much wider than this. The geographer not only tries to know, but he tries to understand and even analyze. That is, he brings in the how and why aspect in his studies in geography. Again, let me give an example to you. Initially, geography was just saying that the population in the Ganga plains is very dense, but they never said why and how we are going to tackle this problem. Okay? So thus we see that the scope of geography has widened a lot, and as soon as the geographers try to analyze the different geographical phenomena, naturally they have to depend on science. Because many of the geographical phenomena have explanations in subjects like physics, chemistry, biology, and even mathematics. Now, although the scope of geography has evolved, but the textbooks, unfortunately, they tend to remain the same. That is, they are full of facts, full of information, very descriptive in nature, and they do not explain the phenomena behind each of the geographical phenomena. Now let me give you an example. Now for example, in a geography class, the students are learning about the shape of the earth. Now in the geography textbook, it is said that the shape of the earth is an oblate spheroid, and thereafter the textbook explains what you mean by an oblate spheroid. It is bunched at the equator, flattened at the poles. Now maybe in the secondary level, another line may be incorporated in the textbook saying that the rotation of the earth is responsible for such a shape. Then the discussion goes on to another thread. It discusses what are the various experiments which have been done to explain the shape of the earth, but nowhere does it explain how the rotation of the earth is responsible for this shape. Now, a child may be very curious to know that how the rotation of the earth has an impact on the shape of the earth. So what does the child do? He looks at his teacher, geography teacher, and asks the question. Now, a geography teacher without a science background, how will he answer this? Either he will say, ask your science teacher, or if the geography teacher is told that you have to explain certain science laws, to explain certain phenomena, she may react saying, already the course is too vast. I find it so difficult to complete my syllabus. So how can you expect me to discuss science in the geography class? Now where does the child go? Now let's see what happens in a science class. Now in a science class, when the teacher is teaching gravitational force, centrifugal force, centripetal force, is she connecting her lesson with the rotation of the earth and the shape of the earth? I doubt it very much. She may be explaining the phenomena through the same example of a child going in a merry-go-round, or a stone. If you just tie a stone with a string and just go on circling the string, those are the things which are taught in the science class. And therefore, and it can also happen that, so there is no connection that whatever that the same thing can be explained with the rotation of the earth can be dealt in that science class itself. But the science teacher generally does not do it. Or it can also happen that the science teacher is teaching a topic on, say, sound. And suddenly the student asks a question on the rotation of the earth because the geography teacher has asked him to do so. Now suddenly in the middle of the class, when the science teacher is teaching a topic on, say, sound, and the student asks question on rotation of the earth, what will be the reaction of the science teacher? She will say, now just ask questions which are relevant to the topic being discussed in the class. Don't ask any questions beyond that. So where does the child go? His curiosity is not met. So this is the problem that the child faces, and he gets a lot of information from different subjects, but he cannot see any connection between them. And therefore, the child is left confused, and at the end of the day, to him, the subject becomes drab and uninteresting. Now this is the problem which I have seen as a teacher, and in this paper I have made an attempt to explain some of the geographical phenomena through science. Now as it is not possible to discuss or take up all the geographical concepts, what I have done, I have taken few concepts which the child learns generally from class 6 to class 10. And before I move further, I would also like to make a point that since I do not have a science background, my explanation of the geographical phenomena to science is pitched at a very low level, at a level to which a geography teacher will feel confident and at the same time will be able to explain them to the child. Now, these are some of the topics I thought of covering in my presentation. Now, I'm not going to teach, but I've chosen some questions which when I was a student in geography, I was studying all these, I had certain questions in my mind. And at the same time, some of the questions I've taken when I was a teacher, the questions the children, they asked me. So, through a question and answer, I'll be explaining the different concepts in geography. And during my presentation, in a particular slide, if you have some problem in understanding, then ask me questions then. Otherwise, if you have some big, larger questions to it, you can ask me after the presentation is over. I'll take your questions and I'll try to answer. the first topic which I have thought of discussing is the sun, because this is a very well-known topic and these are some of the information which a child gets when he is studying about the solar system. And this information is based on the sun. You can see that generally this child learns that the sun is the center of the solar system. It is the nearest star to our planet Earth, and its importance to the Earth is remarkable because it not only holds all the planets together in the solar system, but it is the source of heat and light which has made life possible on the planet Earth. Now, when the teacher says so many things and the textbook is crammed with so much of information, the very first question which the child generally comes up with, that if the sun is the main source of heat and light, from where does the sun generate this heat? Now this answer is very science related question. And how does the geography teacher tackle? I am not trying to put down the geography teacher. What I am trying to say, the connection. Like from the geographical perspective, the geography teacher generally will go on with this. First, she will try to explain the different structure of the sun. As you can see here, the innermost layer is the core. Surrounding the core, we have the radiation zone, and surrounding the radiation zone, we have the convection zone. And above the surface of the sun, we have the sun's atmosphere, which consists of photosphere, which is the innermost part and the only part that we can see. And surrounding it, we have the chromosphere and then the corona. And to answer, after explaining the structure of the sun, the teacher will say that at the core, that is the innermost layer of the sun, a process known as nuclear fusion takes place, as a result of which the sun generates heat and light. Okay, and it ends there. Now what will happen to the child? What does he understand about nuclear fusion? To him it is just two words, nuclear and fusion, and nothing else. So does the child understand how the sun generates this heat and light? Whereas the same topic is discussed in detail in a science textbook. Now in a science class, the teacher will explain the same concepts in a much greater detail, saying that at the core, because of this gravitational force of the sun, it will pull all the gases towards the core and there will be an intense pressure developed at the core. Now this will cause two atoms of hydrogen to fuse into helium, and since helium is less massive than hydrogen, as a result of which difference in mass is converted into energy according to the Einstein's theory of relativity. Now this energy is emitted in different forms of light. It can be ultraviolet radiation, it can be X-rays, visible light, infrared, microwaves, radio waves and so on. And this light, because of this nuclear fusion, an outward pressure is, you can see those arrows going out, and outward pressure is generated because of this energy which is released. And this light is then carried from the core to the radiation zone, from the radiation zone to the convection zone, and this is how we get heat and light. Now again, let's go back to the child's position. He learns all this thing in the science class, but will he connect this learning or knowledge with the fact that how important this light is to the sustenance of life on the planet Earth? He will just go through the process. He will know, okay, two atoms when they fuse together and form helium, this is what happens. He is no way connecting this knowledge which he has got with the geography lesson in science which he has already studied, that this heat and light which is generated by the sun is so much important for the planet Earth. So again here we see that there is a gap. Although the child is learning in both the classes, but there is a gap in understanding or in correlating the knowledge. Now, the next question which I used to face when I was a teacher, many a times the children used to ask me, is the heat and light generated by the sun everlasting? Now, this is not a topic in geography, because in science they do study that the stars also die out. But when we are dealing with the sun as a star, we generally do not teach about the death of a star, because we know that we have taken it for granted that the sun is there, okay, and it will be there for the next 5 billion years. So in geography class, we generally don't discuss this. But if the student asks this question, it is not irrelevant at all, because the student is learning science and he has every right to ask such a question. It is very much to the topic being discussed in the class. Now, from the science perspective, now the explanation is as follows, that the sun has already burned for 4.5 billion years, and in this process, it has this nuclear fusion process, it has used up about half of the hydrogen atoms. So for the next 5 billion years, there is another half of hydrogen which can continue the nuclear fusion. Now after that, what happens? There will come a time when the sun is full of helium gas and hydrogen is not there. So automatically the nuclear fusion will stop. Now with the stoppage of the nuclear fusion, the outward radiation pressure will not be there. So the previous slide which you have seen, those arrows, so as soon as the nuclear fusion stops, automatically the outward pressure is not there, as a result of which the core will contract. Now contraction causes heating. So as soon as the core becomes very, very hot, the helium will fuse into carbon. And then this carbon will not, the core will become hot. Then after that, when there is no more helium and the sun is full of carbon, then further heating does not take place and the sun or the star starts to cool. Okay, and then gradually it will become a white dwarf and later to an invisible black dwarf. So that is the end of the star. This is a topic which is taught in science. But the teacher does not, science teacher in most probability will not connect what will happen to the life on earth when the sun is not there anymore. Okay, so the children knows, but in different forms. The knowledge is there. It is discussed in science, it is discussed in geography, but that connection is missing. So that is not discussed by the teacher. Now, so this is about the sun, and next I will talk about a phenomenon which is very much related to the sun, which is known as the auroras. Now last week I was reading the Times of India about solar spectacle. How many of you have read that article? There was an article on that. Anyone have read about it?
Yeah.
Okay, so that article is about the auroras. Okay, it dazzled the night sky of Norway, and these are known as the northern lights. Actually, when I was preparing my seminar paper, when I had to choose which are the topics which I am going to deal with, I was not very sure whether I will be dealing with auroras, because it is a phenomenon which does not happen in India, like you cannot see from India. So how much the child will be interested to know about it, I was not very sure. So I was just contemplating whether to use this information in this presentation. But when I read this topic in the, this article in the newspaper, at once it came to my mind, suppose I was a teacher, still a teacher in a school, the very next day I am quite sure my discussion would have been on the auroras. Okay, so I thought, okay, let me take this topic in the seminar. And then I just checked some of the geography textbooks about what is aurora, and I was amazed to see that all the textbooks, they just defined what is an aurora. And according to the definition, auroras are explained as a spectacular colored lights that appear in the night sky in the far northern hemisphere, where it is known as aurora borealis or the northern lights. In the southern hemisphere near the Antarctic, it is termed as aurora australis, and it ends there. All the textbooks, only the definition. It does not address how the phenomena happens, why the color varies, or why such phenomena happens only near the poles. So these were some questions which I did not get in a geography textbook, and I had to read, topics from physics. I had to refer the physics book, and even the physics book, it was too high for me because I don't have a science background, so I was finding it very difficult, and immediately I called up Manish. Manish, can you help me? And thank you, Manish, for spending some time with me, and he explained to me how these auroras happen. So this is how it is. Now we know that at the surface of the sun, the temperature is very, very high, and at this temperature, collisions between the different gas molecules are very frequent and they are very explosive in nature. As a result of this collision, free electrons and protons they are released, they are thrown from the sun's atmosphere. You know that the sun is also rotating on its axis. So because of this rotation from the sun's atmosphere, these electrons and protons, they are just thrown out and they move towards the earth by the solar wind. Okay? So the solar wind will take all these charged particles and towards the earth, and once they enter the earth, then there will be some collision with the gas molecules of the earth's atmosphere, and these auroras are produced. Okay, so this is the phenomena behind it, and so we can see that the charged particles are actually the ammunition for the auroras to happen. Now how this happens, we have to understand a little bit, we have to go deeper into science about and learn about the Earth's magnetic field. Now in this slide you can see there are two diagrams. The first diagram, that is this one, it is actually showing the Earth's magnetic field in the normal Earth's magnetic field. Now first let me explain what is a magnetic field. Now magnetic field is actually, they are formed due to the motion of electrical charges. Okay? And since we cannot see a magnetic field, through lines we represent them, and here in the first diagram you can see that there are some lines which are going into the earth from the north pole and coming out through the south pole. Okay, and the lines are very close to each other, suggesting that the magnetic field is very strong there. And away from the earth you can see the lines are quite far apart, which shows that the magnetic field is quite weak there. This is a normal Earth's magnetic field. Now the other diagram shows what happens to the day side of the magnetic field when it is because of the solar wind. Okay, so the next diagram is actually, you can see the yellow one, that is the sun, and the solar wind, it is blowing towards the day side of the magnetic field and it is compressing them. Now soon as it is compressed, the magnetic field changes its shape. So the day side is compressed and the other side it is blown towards as a tail, which is known as the magnetotail. And this compressed magnetic field is known as a magnetosphere. Now, when these charged particles, they come and hit the Earth's magnetic field, they zoom along the magnetic field lines in spirals. And some of them enter the Earth's atmosphere through the poles, and once they reach the Earth's atmosphere, at the upper layers, that is the ionosphere, they will react with the gas molecules, mainly oxygen and nitrogen, and they will form the auroras. So this is the phenomena behind it. Now, the question is, why auroras occur near the poles? Now you can see the diagram, I don't know whether it's very clear. The shape of the magnetosphere, you can see it is compressed and elongated, but near the polar region there is an opening. Because of this, solar wind, there is an opening which is known as the polar cusp. And through this opening, the sum of the electrical charges from the sun will enter the earth. The rest of it is zoomed and moved away. Okay? So because they enter this, there is an opening at the polar region. So the electrical charges, they enter the earth through these polar regions, and that reaction or collision takes place and auroras are formed. So that is the reason why they happen near the poles. Can I proceed? Now, why the colors are different? Now you have seen that there are colors of red, colors of purple, colors of pink, yellow, green, and so on. Now this is again because of with which gas molecules they are colliding. Now we have the two most important gases which we have in the atmosphere is oxygen and nitrogen. And at the upper layer in the atmosphere, oxygen is very common, and when these electrical charges come and collide with this oxygen at upper layer, then they emit, the collision emits red light, and we see the auroras as red. But if such collision takes place with the oxygen at a lower level, then the color of the auroras is yellowish green. Whereas if the collision is with nitrogen in the lower levels, then the color is something purplish or violet color, purplish red, that pinkish color you get. So this is the reason, depending on with which gas molecules the electrical charges they are colliding, the color depends on that. So we have answered the next question. Manish, my explanation is correct?
Just wanted to say that it's over, or you have
or no? Just the A. Now, so through this map, it's only showing the northern hemisphere. I've tried to show which are the areas which commonly see the aurora borealis. You can see it is covering the northern parts of Canada, but northwestern part is more, the auroras are very frequent. Then the southern part of Greenland, if you can see this, this is Greenland. So Greenland, then you have Iceland, then the northern coastal areas of Norway, and the coastal waters north of Siberia. So this is the ring, the green colored area is the areas from where you can see the aurora borealis, right? And in the southern hemisphere, I have not shown it here, it is near the Antarctica region and also near the southern Indian Ocean area where we can see, but there it is known as aurora australis, not aurora borealis, okay? So this is
one question.
Yeah.
Is it seen all through the year?
No, not all through the year. When the solar wind is, the electrical charges are emitted in large, huge amount, then only it happens. And it will last for, 20 minutes to 40 minutes, like that.
Is there a season for it? Is there a season?
I don't think so there's a season, but after 11 years, I think it is more common.
It's similar to what we talk of this Earth atmosphere, right? We have a season here. So similarly, when we talk about the Sun atmosphere, we also have a pattern of how the solar wind intensity increases. So actually, you can see the pattern, and based on that, there are various research are happening at South Pole and all. So when you go there, actually the pattern, what happens? The solar wind is what it consists of a charged particle. Like if you have kind of solar wind, it's like all planets are immersed in a sea. It's called what we call solar wind, which is a charged particle, sea of charged particles. So the flux of charged particle is entering. So if its intensity increases, then you will have a mini charged particle coming into the Earth atmosphere. By nature, it actually what happens that Earth magnetic field is supposed to stop them. It basically acts as a shield for us, like the Earth atmosphere acts as a shield to stop ozone. So Earth magnetic field also acts as a shield to stop this charged particle. In spite of that, few charged particles enter through the pore. So therefore, you will see that those charged particles with a highly charged, with a highly energetic, those only can enter. Therefore, you need to see the pattern when the solar maxima will occur. There you will see the most charged particle entering the Earth atmosphere, and you will see. Now, one more point which I wanted to say here. It will be interesting in a classroom if you ask children what are the where on which different planets you can actually see aurora. To see auroras, the two components are important: atmosphere as well as magnetic field.
Right.
Now, most of the planets have magnetic field, but those planets who does not have atmosphere, you cannot see the auroras.
Okay.
So that will. Now we move on to another topic, which is the atmosphere. And as you can see, I think all of you know that atmosphere is the gaseous component which is surrounding the Earth, and it is mainly made up of oxygen and nitrogen. Now here I have shown the different layers of the atmosphere. The lowest layer is the troposphere. Above the troposphere we have the stratosphere. Above the stratosphere, mesosphere, then thermosphere or the ionosphere, and ultimately we have the exosphere. Now, the questions which are generally asked by a student just soon after knowing about the sun and all, we move on to the next lesson about the atmosphere. That if the sun is the main source of heat and light, then how come the temperature decreases with height? We know that the closer to the source of heat, the temperature should be higher. And you are saying here that sun is the main source of heat and light. In that case, the layers of the atmosphere closer to the sun should be having a higher temperature. But it is the other way around. You are saying that the temperature is more near the surface of the earth, and as you move up, then the temperature goes on decreasing. Why is it so? Now, to answer this question, we have to first look at how the geography textbooks tries to discuss this phenomena. Because to answer this, we have to know how the atmosphere in the earth gets heated. Now, this diagram actually gives how the heat is distributed from the sun to the earth and how it goes back to the atmosphere. Now, the rays which are coming from the sun, they are known as the insolation. And in the textbook, you will find that they will say two things. That the insolation coming from the sun is in short waves, and although it is passing through the atmosphere, only 14% of the atmosphere gets heated by this insulation. Some of it is scattered and the rest of it comes and heats up the earth. So it is passing through the atmosphere, but only 14% of the gas in the atmosphere is getting heated up. Now the earth intercepts this heat, and in the evening it will start giving off the heat because it has to maintain the heat balance. So it will start giving off the heat, and this heat, that arrows which you see coming from the earth, that is known as the terrestrial radiation, and it is in the form of long waves. And this terrestrial radiation is responsible for heating the atmosphere. About 85% of the atmosphere gets heated by this process. So first the lower layers of the atmosphere gets heated by conduction with the earth, and this heat is then passed to the upper layers of the atmosphere by the process of convection. And therefore the lower layers which are closer to the earth are warmer, and as you move higher up, the temperature goes on decreasing. So this is the explanation given in science. And as a student, my teacher also gave me the same explanation. But I used to get confused. First of all, I didn't know what is a wave, what is the difference between short wave and long wave, and why does the sun emit short waves, and why does the earth emits long waves. So these were so many questions in my mind which were never addressed, neither in the textbook, and I also did not get a proper answer from the teacher as well. So if this topic is to be introduced in the classroom, how does the teacher plan his lesson? So I think some idea about what is a wave and what are short waves, what are long waves should be given. Now the first figure here shows the wavelength. Yes.
Which textbook did you mention? Which grade actually?
This is generally start from 6 to generally class 8.
Which age is one set?
So 6 to have taken concepts from 6 to 10, and generally this is taught in class 8. Now the wavelength, as you can see in the figure, the distance between crest to the next crest is known as the wavelength. Wavelength can be short, wavelength can be long. So if the length of the waves are very close, packed together, then we say short waves. And if the length is the wavelength far apart, we say it is long waves. Now this animation, why I wanted to bring it is to explain why the objects which are very hot, they generate short waves, and why is it the objects which are cooler, they generate long waves. Now here you can see the two children, they are holding a string, and one of them is having a drilling machine in his hand. Now as soon as he starts operating the drilling machine, the more the times of revolution in the drilling machine, the more energy is generated. Can you see that?
Yeah.
So more energy means more energy will have more number of waves, and they will be shorter, they are very close, tightly packed. Whereas when the boy is not using the drilling machine, you see the string will have a very long wavelength. So this animation is really, I understood it so well, and had I been told when I was a student, then that confusion wouldn't have been there, because as a student, whenever I was preparing myself for the exam, I used to go and refer to the textbook, does the sun emit short waves or long waves? I really used to get confused because I did not have the logic behind it. So often I used to keep on referring my textbook, am I saying the correct thing, that the sun is emitting short waves and the earth is emitting long waves? So that confusion was there. But if the teacher, before introducing this lesson, just gives a rough idea, it doesn't even take 5 minutes, but if the teacher gives an idea, then the child immediately will not have a problem in understanding why, even though the rays of the sun is passing through that. And another thing which I forgot to say is the short waves, they get scattered, so absorption cannot be more. Okay, so if the teacher just introduces 2-3 points on this before teaching this lesson, then it becomes so clear to the child. The child knows that the atmosphere absorbs only 14% of the insulation coming from the sun, which is in the form of short waves, because most of them get scattered. Absorption is not possible. Whereas when the earth is emitting terrestrial radiation, it is in the form of long waves, which the atmosphere can absorb, and 85% of the terrestrial radiation is absorbed by the atmosphere, and therefore we can say that the atmosphere is heated directly by the earth and indirectly by the sun. Therefore, for the atmosphere, the source of heat is earth, and therefore the higher you go, the cooler it gets. So such a simple explanation, only with 2 or 3 lines in the beginning of the chapter can make so much difference to the child's learning. So before this, yes?
Just small correction.
Yeah.
Go back, when you are saying the temperature, just go back to one slide.
This one?
You are saying the temperature decreases with the altitude, right?
Yes.
Can you show me your profile of atmosphere which you have shown? Before that. Yeah, so this is one point of clarification. Actually, if you see the temperature gradient profile, vertical temperature gradient profile, this temperature decreases with altitude.
In the troposphere. In the troposphere, right. I did not go into such detail.
Yeah, so when we are talking about
the troposphere,
geography,
yes.
the immediate atmosphere is up to troposphere.
Right.
Troposphere, yeah.
Right.
After that, like.
But as you go up, it increases.
Again decrease like this.
Why does it again decrease?
Ionosphere, the temperature will be very high because of this, radiation and all this. But in the stratosphere, the density of the atmosphere also keeps on decreasing. So that absorption is much less. Am I correct?
Go on. So actually, it won't be so straight forward answer to this. What happens at different levels, we have a different phenomena happening. So in a troposphere, mostly, as she is saying that, of course, this ion density will keep on increasing. But as you go up, you will see the electron density start increasing.
Okay.
So those two phenomena, the pressure start decreasing. Okay. Therefore, the temperature also changes accordingly. So if you go to the beyond, say, the stratosphere, you will have ozone and O2 dilation happening around, which decreases. And then you have a third region which is called thermosphere. You have more thermal ion things happening around. So the various phenomena, because of which you get a temperature gradient profile, it increases, decreases, increases, and then goes on increasing. So like that.
And Manish, in one of the textbooks I found that in the thermosphere, the temperature is very high but the heat is less.
Actually, you will not feel the
because the gas density is so less, so the heat is not much, but the temperature is very high.
Temperature is very
So
high.
I do not want to go into such in depth because I won't be able to maybe handle it.
You wanted to say something?
Yeah, actually, the temperature is defined as the kinetic energy of the molecules
Right.
or the atom. So
Right.
even if the temperature is so high, you will not feel the heat because as they impinge on you, they deliver that energy. So you will feel the heat. So even if the temperature is high, you will not feel because the number of ions or molecules or whatever exists there is very less.
What he is saying in broader thing is that I think those, because if you have a very small number of ions moving at very high velocity, and if you have hand obstaking it, you won't feel any heat impact because the ions are very less. But instead of that 10 ions, if I have 1000 ions and then I keep my hand with the same velocity, you will feel heat. So that's the simple explanation.
Thank you.
So why is that?
Take it out. Now next I want to say a few words on the shape of the earth because my introduction started with that. Okay, now geodesy is actually the branch of science which deals with the shape of the earth. Now in the introduction part I had said that the reason behind the shape of the earth being an oblate spheroid that is bulged at the equator and flattened at the poles is because of the rotation of the earth, and the textbook stops there. Now, I'll just take it a little bit further. Now, why the shape of the earth is related to the rotation of the earth is because the speed of rotation is not the same everywhere. This is not taught in a geography class, especially from class 6 to 10. We assume that the speed of rotation is same everywhere. But we know that speed is equal to distance by time. So at the equator, if you just calculate the speed at the equator, now the distance here is the circumference of the equator, which has been computed as 40,070 kilometers, and the time taken to make one rotation is 24 hours. So the speed of the earth at the surface of the equator will be somewhere around 1670 kilometers per hour. But since the speed is dependent on the distance and we are calculating in terms of latitudes, and we know that the circumference of the latitudes, they go on decreasing as one moves away from the equator. So smaller the distance, obviously the speed will become less. Okay? So say at 45 degree north or south latitude, the circumference is much smaller. So obviously distance and the time taken is the same. So distance by time, the distance, kilometer distance is less, automatically the speed is less, and at the poles the speed is negligible. It is just a spin, a point just spinning round. Okay. Now because of this, what has happened that about the shape of the earth, how it has impacted. This is in the early beginning when the earth was forming, it was in a semi-molten state. Now because of this going round and the speed was more at the equator, so the centrifugal force was also very high. You know that more the speed, the outward force, that is the centrifugal force will be very high, as a result of which much of the matter from the polar region has just moved and accumulated near the equator. As a result of which it has resulted in bulging at the equator and flattening at the poles. So this is a very simple explanation, but actually the geographers who have really calculated, they have used cosine and all to explain this, and which went beyond my understanding. And this is a simple way how a geography teacher can explain to the students in class, and they will also get a feeling, okay, what has actually happened. And this is what I have tried to do. So this is the explanation beyond it. So
the earth should have flattened then.
sorry?
The earth should have flattened.
Flattened? No, like then the matter becomes solidified. No? Matter, it has happened in the early years when it was in a semi-molten state, and it did not happen suddenly.
But it was millions of years.
Yeah, it took millions of years, and then I don't know whether the shape will change further. Or at the same time, the earth has become solid, except the core and surrounding the core, that part, it is semi-molten, otherwise it's solid. So solid material, the impact I do not know actually. Now gravitational force, why I have brought in here is, this force actually explains many of the phenomena in geography, especially why the planets, they stick to their own orbits, why they do not move away. That is explained through gravitational force. And again the tides, how the tides are formed, that is again explained through gravitational force. So I have got in here because there are some interesting facts which I did not know before while I was preparing for the seminar. Although it is very, very, basic thing, but I did not know that the gravity is not the same everywhere. The gravity increases with the increase in latitude, because at the equator, because of the bulging at the equator, so what has happened, the distance from the center of the earth is more, and gravity depends upon the distance from the center. So at the equator, gravity is less. Not only because of that, again centrifugal force is opposite to that Newton's law of motion. So wherever the centrifugal force is high, the gravitational force will be less. As a result, there is a difference in gravitational force, but this is very minor. Therefore, the question you can ask is, do you weigh differently at the North Pole than what you do at the equator? The difference is very negligible, but yes, whatever you weigh at the North Pole, the equator will weigh less because of the less gravitational force. Now next, any questions on this or any discussion you want on this? Okay. Now next we move on to a topic which is of very, very interesting to me, that is the ozone hole. And I think many of us, keep reading articles on ozone hole, and I do not know, before taking up this topic in my seminar, I did not know much about it. And I remember when I went to Shorapur 2 months back, there was a discussion. I was trying to help the teachers in geography there with this concept, and where suddenly I was, it came to that I could not answer everything. So then I again came back, read, and now I am going to present. Maybe that also will not be enough, but whatever I have understood, I will just present here. Now when we talk about the ozone hole, can you see the red band there? That is the ozone, O3. And this ozone is found both in the troposphere and the stratosphere. But when we talk about ozone hole, we are actually referring to the ozone layer which is found in the stratosphere. And this is very important because it absorbs the ultraviolet radiation and it does not allow the ultraviolet radiation to reach the Earth's surface, and therefore it protects us. But in case there is a hole in the, what I mean the hole, it's not literally not a hole, but actually it is a depletion of the ozone gas. Now, suppose there is depletion of the ozone gas. So naturally all the ultraviolet radiation will not be absorbed. So some of it will just come to reach the Earth's surface, and that will create a problem. lot of skin cancer, and not only human beings, even plants. It is it's a real problem with the ultraviolet radiation seeps into the Earth's surface. Now, it has been proven that this hole or depletion of the ozone hole is because of a compound which is known as chlorofluorocarbons, which is in short known as CFCs. And these CFCs are responsible for the depletion of the ozone hole, and this CFC is man-made. Okay, this compound is actually not found in nature, it is man-made. Now let's see what are the different areas where these chlorofluorocarbons are used. Now these are used as a coolant in the refrigeration and air conditioners. They are also used for cleaning the electronic components. They are used in the aerosols. So we were just having in Shorapur, as I was mentioning, we were just having a discussion, and I thought I knew so much about ozone hole, and I was trying to help the teachers. But suddenly, the question, okay, before I come to that, okay, the question was, like, when you are saying it is man-made, and then Antarctica you are saying is the largest hole found, then if it is a man-made compound, how come near the Antarctica you have the ozone hole is maximum? And I was taken aback, I couldn't give a proper answers, I fumbled, and then I said, okay, I'll look into it and I will study. But before that, let me just explain how the CFC, they destroy the ozone. Now CFC, as you can see, the green color, those are actually chlorine, and the black one is the carbon, and the blue one is the fluorine. And here I would like to thank Syed Masoom, to help me understand this. Syed, are you listening? Okay. Now this is the CFC, and when
you want to point out?
no, it's okay. Is it okay?
Yeah.
So when the ultraviolet radiation, it comes and it reacts with the CFC, a chlorine atom is released in the process. Now this chlorine will come and react with ozone, that is, you can see 3 oxygen molecules. So it will just react with ozone, and as a result of which it will form ClO, that is chlorine monoxide, and it will release oxygen molecules. Now this ClO or chlorine monoxide will again, there is an oxygen there is a nascent oxygen atom coming. It will combine with that oxygen of that ClO, and it will just move away, and again chlorine is released. And this chlorine will again come, and you see the cycle it goes on, it will again come and react with the ozone. I hope the diagram is clear.
Yeah.
So this continues, this process continues, and CFC actually, it is a very stable compound. But because of it is very stable, it has enough time to gradually, go to the Earth's atmosphere and start this reaction. Right? But the question is, if CFC is man-made, then why the ozone hole is maximum over Antarctica? Okay? And here you see the white, this is the map of Antarctica, and the blue part is actually showing how much area of Antarctica has been affected by this ozone hole. And again, this ozone hole is not, is not the same size. It is maximum during the spring, and in summer it becomes very less. Again, to repeat the same process. Now, the reason behind this is because, in winter, when I am talking about Antarctica, winter means mid-May, because it is, the southern hemisphere, they have seasons opposite to ours. So, in that is in mid-May, when the winter season sets in Antarctica, and that is the time when there is no sunlight. So, the temperature is very, very low. It is around -80°C. And at the same time, I won't go into very hi-fi explanations, a polar vortex develops, which is very westerly winds which circulates at a very high speed, and it separates the Antarctic stratosphere from the rest of the area. So I am not going to so detail, just it is like this, that winter sets in the month of, say, middle of May, and there is no sunlight and the temperature is very, very low. At such low temperature, -80°C, it helps in the formation of polar stratospheric clouds, which in short is known as PSC, and it is made up of very tiny ice particles, and this provides a surface for the reaction of the release of chlorine. Okay, so there are pockets of reservoirs of chlorine, like some compounds there, and with the reaction with the ultraviolet radiation, this reaction starts on the surface of the polar stratospheric clouds. Now the question which had come to my mind, then why not Arctic region? Why not
Exactly. I
Antarctica?
was just going to ask you that.
Okay. So again my explanation will not be very, what I understood. Arctic Ocean, that region, Arctic region, we have both land masses and water bodies. Okay, and the polar vortex is not strong enough, and it says in the science book it creates some Rossby waves. I don't know what is a Rossby waves, which does not allow the temperature to dip as low as -80°C and the formation of the polar stratospheric clouds. But if you ask me the details of it, I do not know. This is what I understood.
No, but
There are hot streams there.
Hot streams there, right? Okay, hot streams are
Doesn't allow
the polar vortex to develop.
Yeah, doesn't allow the temperature to fall.
Fall down. Okay.
no, it's quite clear temperature is an important factor.
Right.
How did that CFC get to the Antarctica?
Now, see, Antarctica is not that CFC is not producing the whole. That ultraviolet radiation, when it there is chlorine, other compounds also.
Where? How did it come to Antarctica? That's the question. Antarctica
It is there in the atmosphere.
So what
These are what he's saying is the CFCs are distributed through that whole across only over Antarctica for these reasons.
CFCs are distributed across the atmosphere
Everywhere.
but they are not man-made then.
They are man-made, but because atmosphere circulates, it's circulated everywhere.
It goes that far back. It goes that far down.
No, it is here also, Neeraja. It is here also.
But here it is there, I understand.
Yeah, but
Since there are no people there.
No, see,
In the
CFC produced in the US, carbon dioxide produced in the US, they have traced it to the Himalayan region within about 3 or 4 days or something.
Okay, I
So
didn't know that.
that kind of circulation happens.
Oh.
So the CFCs are circulating in the atmosphere throughout. The ozone hole occurs only over the Antarctic region for this.
Because these
for
specialists.
This polar stratospheric clouds.
Fine.
Okay? And although this polar stratospheric clouds it forms in winter, okay, it is in abundance, but this reaction does not start then because there is no sunlight. Because the reaction will start to meet the ultraviolet radiation. So during spring, which is from the month of August to October, when the sun again starts shining, and the ultraviolet radiation it comes, and then the reaction over the polar stratospheric cloud starts. And in the process it will release chlorine, and as you had seen earlier how the chlorine comes and attacks the ozone and how the reaction happens. This is how the ozone hole becomes very large in the Antarctic region. But with time what happens, the summer approaches, the temperature will rise, and automatically the polar stratospheric clouds will disappear, and then the ozone hole also becomes less, and the process shuts down, and again the hole will shrink, and again the process will start happening from winter, which will happen maximize in spring. So this is how, I think I have tried to explain as much as I could why it is in Antarctica.
There are a few important
Yes.
things related to ozone. First thing is that I don't know whether you have covered that or not. Actually, naturally, it's not that only the breaking of O3 happens into O2 molecule and nascent oxygen. Reverse also happens. They also combine to form ozone. So what we have done, that is a man-made CFC and all that, we basically imbalance that equilibrium.
Yeah.
Right, that's the one cause. Antarctica regions are thin atmosphere. That's the second cause, and why that thing happens during Antarctica region over. And secondly, thin atmosphere. Antarctic region and polar are always a thin atmosphere as compared to other regions.
What does it mean?
Densities. You're talking about the molecules densities and all are very less. Those two phenomena. And secondly, you need ozone also. Because having ozone actually help you to absorb the harmful IR. So it's kind of, you want ozone also, but you don't want more ozone. Because if you have more ozone, then it will lead to problems. So our man-made thing is that we are imbalancing this equilibrium, which was naturally quite balanced. Therefore, all this problem has started happening. So what important thing is to know that. It's not that only because of CFC things has happened. Even if we don't have a CFC, then equilibrium things will happen. Because people have this thing that having an ozone is always harmful. It is not like that. It works both ways. But because you have imbalance, and therefore the problem arises.
Now coming to my conclusion, I have explained all this geography. So we see that geography has got strong linkages with science. But that does not mean I'm trying to say everything, all children, they learn best when they can make connections between the units, the topics which they are learning. But that is not happening. They are getting lots of information in different pockets. That connection is not happening, and therefore I feel that we should try thinking of designing a curriculum where we teach the different subjects as independent subjects, but whatever topic we are dealing with, we can have units which run across through the other subjects as well, so that we have the children can find that connection between them. So this means, I'll just give you an example. Suppose when in the geography class, the teacher is talking about auroras. If in the physics class, simultaneously the teacher can talk about magnetic field and all, it will bring sense to the child, and the child will be able to relate that learning which is happening both in geography as well as in the physics class. Similarly, suppose the student in a geography class is learning about karst region or chemical weathering. If during at that point of time in the chemistry class, if the teacher is teaching about, acid rain and all, it makes more sense. Similarly, like a biology teacher and the geography teacher can sit together and plan a lesson on the adoption of the mangrove forest on a saline soil. So if this connection can be built, then it makes more sense. And in that case, we won't be able to follow the textbook chapter wise. Obviously, we have to plan our textbook also accordingly, so that all the topics or units cuts across all the subjects. And I know it's quite a mammoth task. It is not easy. And especially with whether this idea will float in this current, present, educational system in India, I do not know whether that will happen as well. But at least we can give it a try. If we start thinking, that thinking is actually, if you just don't think, nothing will happen. But at least if you can start thinking, and we start in a very small way, we can start from the primary level maybe, and gradually we see whether it will succeed or not. Then I think we'll be helping the students to have a holistic idea, and they will enjoy the learning, and they will enjoy the learning process so much that they will not find any subject as uninteresting and dry. So this is my suggestion. I don't know. So these are the references, and thank you.
Slideshow.
Relation with the geography and biology, relation this one evolution and this is geography, something like that. And bring out this one article.
We could even have a demo like that of 3 people.
Actually,
Across what you suggested, we could actually have a demo. While this is being taught, this will be taught, that will be taught, so it will bring it together in our minds.
It's a lot of planning.
Yeah.
We should start thinking. It's just not, I'm a teacher, I might be a teacher, but the thing is, it's not that after your class, last half an hour or 1 hour, you sit together and decide. It will not work.
Yeah.
But this is what generally what the schools do.
Yeah.
The teacher, they are not given, okay, you have 3 months time, sit, discuss, you don't have to go to the class or plan.
Yeah.
That is not there.
Yeah.
The teachers after the class, okay, the last 1 hour, you can sit and discuss. Then nothing happens. Like you need to think.
Yeah, sure.
You are a teacher and a very good student also. So then you can make a very good combination with all people.
Yeah, actually, I'm really very happy that you could put such a great hard work in this, and you could bring out all such really very sensitive issues. Those are really missing in the present geography in India at least. So, as far as the geography as a discipline is concerned, so human geographers and physical geographers, they are, have been fighting each other, and now they are making it in a separate discipline. Physical geography is a separate discipline itself, and human geography is in a completely discipline. But as far as the school education is concerned, so it becomes a very crucial point for a teacher to put all these things together, and however their knowledge construction processes are different actually. Science or science concepts are different and human concepts are different. So it's really takes a lot of hard work to make a balance and to create such a circumstances in classroom so that school student could learn both the things, how to construct scientific knowledge and how to construct social knowledge. So it's really I really congratulate to you.
Thank you so much.
Yeah.
To pick up the geography as a discipline is natural ground for integration. And the dichotomy that is occurring now in geography is sad, and it's very logical because geography is where things should come together and go away. As we were talking, I made a lot of notes to myself, but I don't want to take your time away. One thing that I found is this, when I was teaching in one of the international schools in Bangalore, and the staff room, I used to sit in the staff room and listen to what goes on. The conversations you're talking about, we have not even thought about having a conversation. You know, the discussions centered around, my mate didn't come today, my driver is stealing petrol. It's kind of rubbish. I mean, it's not rubbish, it's serious issues, but not for the staff room. But that's all that gets discussed. So at one point I was going on about, how it's all geography, I keep doing it, just to irritate people. Man, very good at irritating people. And his physics teacher got very upset with me. She said, how can you say that? Geography is the center of the universe. I can say physics is the center of the universe. I said, then why don't you? And she said, but how can both be? Somebody else will come and say chemistry is the center of the universe. Let it be. Let them say, look, let the kids figure it out. It's their problem. Let's start with them and let them be. That's it. So I went back that afternoon. I had geography class at 10th standard. I went and told them about this. Tell her that we had this conversation and what does she think about it. They wouldn't do it. They said no. Because I don't think we talked about those kinds of things. But that is the dialogue that is desperately needed. In teaching, for example, what you studied, you talked about today is physical geography. Yeah? The human connections with that, if we bring that in, there is no end to what we can bring in. And when we do that, suddenly you can actually see why I keep making this claim that geography is it. This is not to say that physics is not it. It is. But when you look at the human being as an experiencer of these things, geography does come into it. So I'll give you one or two examples. One is this, how cholera was tackled in London. It is a simple geographical leap of imagination by a doctor who simply took a map of London and plotted all the places where the cases were coming from and saw a pattern to that they were centered around certain public wells. He shut those wells down, just shut the wells down. Within a matter of a few days, the cholera cases came down. Then they figured it's a waterborne disease, the rest is history. So, that leap of imagination, geography was needed for it. Otherwise, you would have been treating people forever.
Science was needed for it.
Exactly. But notice, he had this science, he was treating people were still dropping dead like flies. I don't know if flies dropped dead because of cholera, but nonetheless. So that is one example. It is interesting with this idea of science and geography coming together and making that imaginative leap. Unless we have that synthesis, it cannot happen. So medical geography as a branch of geography, it's becoming increasingly a branch of geography, brings things together like no other branch of geography does. So when I used to do a series of 3-week series of lectures on the geography of HIV, it is amazing what comes into it, all the way from religious beliefs to people's notions of beauty, to people's preoccupations with skin color, prestige issues, socioeconomic status, where they are located, how they move, everything comes in. So that kind of a topic-based approach, if we take case study-based approach, there will be no issue about all of these things. We can easily, but which brings me to my second point, and that is the curriculum and the textbook are horses designed by a committee, which are actually camels. Camel designed by a committee is what they start with. So that mammoth task you talked about, first get rid of all the curriculum committees and the textbook committees we have now. We should be the ones to do it because we are thinking along the right directions, I think. So, just two of this. It was interesting. I was doing a workshop on monsoons. I connected to everything positive because I love that stuff. But kids always surprise us, telling them about winds. I said, what is wind? Air in motion, everybody shouting and screaming on it. I said, fine. But why does air have to move? My textbook is on pressure, temperature, all of this will come out. While the kids were figuring it out, one girl on my side, I saw a lot of action, I just turned around. She just said, because it's free.
Beautiful.
I said, that was brilliant. That is a poetic leap of imagination. I said, why not? Why not? Why can't we look at it that way? So the rest of the workshop, we kept connecting it back to poetry and dance and music and things like that. And she will never forget the monsoons the way she understood it that day because of that one little comment she made and how the rest of us reacted to it. Some of the kids laughed, some of them said, wow. So, that we don't have space for that in the regular classroom. That is sad.
First of all, I would like to congratulate you for doing this beautiful presentation. I was thinking about something, since you are speaking about connections, and you yourself have been a teacher for a longer time. When you teach, and then when you come out of teaching, and then you start reflecting that what were the question I was dealing with, where I find it difficult to make children understand. And then you reflect and then you connect to other subjects and then you find that, okay, these are the missing links. But do our teachers find the space to think, to reflect, and to bring all these things together and then go back to the classroom? Do they have this space there? Because since you said that you were interacting with teachers and you found that they are having some different questions in their mind. They are not at all thinking about the subject. But do they have the space to think about the subject and reflect and then go back to the children again? That is the question which I know.
That is what the teachers do not have the time, especially if do not have the time and they are not given that opportunity actually. Their days packed in number of classes, and if a teacher is absent, you have to substitute for that class also. So they don't have the time for reflection. It's very, very fun, which is very sad.
In both ways, I think, there is no space even if the teacher wants to kind of think about it. Another question arises along with it is the teacher really interested to think about it? When the teacher is really interested to think about it, she or he will try to create that space. But again, where is that space? So it comes like one vicious cycle as to it is. This is what human geography is.
I'll just differ a bit here. Problem with geography and geography teaching is slightly more specific, and I think it's partly being reflected in the type of questions that you have chosen to focus on in your presentation. And I think Kuldeep has pointed out the conflict between physical geographers and human geographers very well. The crisis at a very deep level is in the geographer's own interpretation of what their discipline is about. And unfortunately, that is getting reflected in very contradictory pressures in designing of the curriculum. I think we tend to go to the teachers and blame poor teachers, but here the blame lies with the discipline of the geographers. The problem is that a geographer is never trained at any point in the mathematics and physics and chemistry and biology of some of the questions that they try to address in the discipline.
Very true. Very true.
So, why does the discipline of geography deal with these questions and not deal with the questions that Kuldeep is pointing out in human geography, which make it so interesting? I mean, your example of monsoon. I remember my geography teacher in class 8. She was a very unique geography teacher. She threw out the formal geography. I mean, she was a very strong personality and she convinced her principal. I was in a school in Rajasthan. She threw out her geography textbook and said that I am only going to do 2 things in this entire year. For first half of the year, we were studying the geography of Rajasthan, the state we were located in, and because some trips were possible, children coming from different parts of Rajasthan, it happened to be a boarding school. So it was a very rich building up of our own, putting together our experiences of both physical features of Rajasthan, the human geography features, cultural geography, the whole lot of it. And then the second half of the year, she said, we'll now look at Kerala, a state where most of us had not been to, but she helped us make that flight of imagination. We have so much of material that we were collecting about Kerala and trying to understand how life in Kerala is different from life in Rajasthan, etc. This is something that the formal geographers refuse to accept as a good, sound geography curriculum. The type of caricatures that geographers are creating, unfortunately. I got one example of it very recently in the state textbook of class 6 for geography, which Bihar SCRT was preparing. And unfortunately, the gaffe that they made there is there in the NCRT textbook also. They put the diagram of the solar system on the cover, and the diagram is showing that all other planets are going anti-clockwise and Venus and Uranus are going clockwise. But this is factually wrong. So I asked those people, sir, वो तो NCERT की textbook में वैसा ही है. So we looked at the NCERT textbook, that has the same problem. I said, but this is wrong. Did you check with any of the astronomy books what they say? No, this is very clear. And these are the professors of geography from Patna University defending. Then it turned out we've always believed that. And what I can decipher is that they're basically confused between rotation and revolution. That the orbits of all the planets are anti-clockwise, and it's only the rotational spin of Venus and Uranus which are not anti-clockwise but clockwise. But there also astronomers have an issue, because for example Uranus, the axis is tilted at nearly 90 degrees. So Uranus is in a way rolling along its orbit. I mean, if the axis is at any angle to the plane of orbit, then you can say that it is rotating like that. But if Uranus axis is 90 degrees, and they can't decide which is the North Pole and which is the South Pole in that. Because the North Pole for Earth is decided by the location of the pole star. Okay. So Uranus they can't decide, because if you take this to the North Pole and that to the South Pole, its rotation also becomes anti-clockwise like other planets. Venus, there is a issue, and people are now coming around to accepting that possibly Venus has a anti-clockwise, clockwise rotation. But with Venus, the other issue is that its rotational time period is same as its revolution time period. So 1 year is for Venus is same as 1 day on Venus. But these are, you see, details of astronomy, astrophysics, which geographers are not trained to go into and are not bothered. And they are saying, the child is going to find a contradiction somewhere in what would be talked of later, say in an astronomy class or in an astrophysics class, and what the geographers are telling him. And please pardon me, but most of the explanations that you got here, in an attempt to simplify, this is something that a problem we've been fighting in science textbooks also. That when we try to simplify a more complicated concept, we end up distorting it rather than simplifying it.
That is why I said, physics teacher should handle physics.
No, the physics teacher will not be able to handle it at the class level at which you are wanting it to be handled. The long wave and short wave can't be talked of at a middle school science level.
Then you have to change the curriculum.
Yes. That is the issue, and unfortunately, post NCF 2005 exercise, most of the subjects in social sciences have undergone almost revolutionary change. Civics has been overhauled, history, the perspective has become so different, etc. But geography still is holding on to the and my perception now is that the problem is not with the teachers, not with the curriculum designers, it's with the people who are, so to say, the protectors of the geography.
Exactly. Those gatekeepers.
Yeah, the gatekeepers. It's a very big problem. They refuse to, and it's not just that there are geographers who are trying to argue to the contrary, but they have not been able to make what Kuldeep was saying. I know that the geographers group in JNU, in the Center for Studies of Regional Development, which was initially led by Professor Munis Raza, unfortunately who is no more, when they wrote the NCERT textbooks, I mean the two textbooks that they wrote for high school level and senior secondary level, were totally different, because they say that at the center of geography are people, human beings, and how the physical environment affects their lives. That is the central question of geography. How our lives are affected by the physical environment around us, and how changes in the physical environment bring about changes in our life. That is the central question of geography. Not why the changes in the physical environment are coming about. But if geographers make that as the central question, well, they'll have to come from, I mean, they are basically an applied discipline. They'll have to come in sequence with the basic disciplines of physics, chemistry, biology, etc. in order to be geology, astrophysics, etc. in order to be able to explain why physical phenomena is changing.
But I think that is where Mahuya is questioning,
yes, that
geography is how physical environment is affecting human life. But while you are speaking about the physical environment, the child might have question about why this is happening. So the connection between human life, physical environment, and why this is happening, that missing connection is needed to be established. Yeah. That is where she is grounding her discussion.
What Kamal is saying, I agree with him. I really appreciate that he could bring all such nitty-gritties of geography. Yeah, sorry. So, I'm just saying that I agree with Kamal what he is saying, and I'm really surprised that he has been so aware about the geography education, at least in India. So, really, I agree with you, and I would like to add one more point here is that in Western countries, geography is really radically changed. But the problem is that we Indian geographers are not taking any insight from them even. So this is the problem. And what Kamalji is saying, he is also supporting the argument of Mahuya actually. So he is not saying anything different.
Can I say something here? Because you have taken one of the points which I wanted to say. So I'll just add up to what I mean by saying that. To me, it's not a question of whether the color of the sky is blue. Shall I ask this question to geography teacher or science teacher? To me, that is not a problem. The problem which Kamal Mahendra was speaking, even I feel that the scientific concepts, the way you are saying that, it seems to be more as a fact in geography class. Now, this is happening because the scientific concept which are using a lower grade of geography being introduced in science classes at higher grade. Now, the question is, can we actually bring down those scientific concepts to that level to explain the geography children at that level, in lower grade? Personally, I feel it's not possible. The problem is concepts of Coriolis forces. Even if you ask the physics student who have passed N+2, they won't be able to explain you. Because as I said that day also, there are few basics in mathematics required to understand physical phenomena. Similarly, in geography, you cannot bring all those higher scientific concepts in that form to a lower grade. It needs to be bring down in a more simpler form. It may be, as you are saying, geography even I believe in. It used to be one of my favorite subjects during my childhood. But the first kind of interaction between geography and science started when I learned that Earth is, sphere and it's round.
the immediate question comes in my mind that Earth seems to have so much of water around, right? It's a sea and all. And it says having the water is not falling. So I immediately asked teacher, why water is not falling? He told me it's because of gravitational force. So I asked him, what is this gravitational force? He said, it's the attraction between the two objects. Now, that time, I think I was in 6th or 7th grade. I kept my book and I was keep wondering why these two things are not getting attracted. No, unless you appreciate the gravitational constant, which is 10 power minus 17 kg. No, that power has so much of value which is getting reflected. Such a negligible force in real life. Therefore, you don't see it, but it is there. It is inherent. So that kind of thing, if you don't bring it, children, as Kamal was saying, sir, you can simplify, but oversimplifying will lead to more confusion. You cannot. Even the same problem happening with the physics. Mechanics are introduced in 11th class without introducing calculus. And that's the biggest problem which I feel, because introducing pre-calculus, calculus only required algebra trigonometry, which children already up to 10th class know. We can introduce calculus in 11th class, but we wait till 12th grade. And we introduce mechanics, and calculus was used Newton to develop mechanics. So how do you separate those two things? And therefore you'll see the most of the children suffer in mechanics. They cannot understand instantaneous velocity unless they have the idea of derivative. So the same thing I see that getting reflected in geography when you compare with the different science.
Exactly.
As I
How do you solve this out?
curriculum. If you need to be changed in the curriculum.
The thing is oversimplification or all those things are fine. In fact, I was about to ask it. See, if a child comes up with that question, and you can't say oh, you wouldn't know. You have to I'm not saying satisfy the child immediately. Okay, given explanation in such a way, the child still burns with the question to find more. But you have to give an answer. Okay, when I'm trying to say yes, of course I do understand for certain understanding of the concept, I need much more bigger laws for which these scientists have worked for their whole age to bring out that law, and where I'm supposed to read it in one term or in one period. Okay, I'm not that brilliant to take in eons of ages what they have done. But I am interested in it. And how will you explain to it?
No, if an 8-year-old asks you, how does the sun generate heat? You cannot explain nuclear fusion to an 8-year-old. What will you do? I understand my question.
See, this is a question which we had to face in training science teachers also. Okay, it's not that it's coming only in geography.
Yeah, I'm asking it.
Okay. And the answer to that question, which every teacher needs to say honestly in the class, is that I don't know the answer to this question.
Sure.
And that there are many questions which we as human race don't know the answer.
But we know how the sun generates heat. So we can't say I don't know.
Yes. No, a teacher can.
Why should a teacher say when she knows?
No, she doesn't know. That's the problem. Many times we don't realize that we don't know the answer and we keep giving wrong answers to children.
I'm asking a different question. Teacher knows that it is due to nuclear fusion.
No.
She has understood nuclear
No.
fusion.
No.
An 8-year-old you cannot explain.
No, please let me finish. Please let me finish. I think there is a deeper philosophical and pedagogical issue which is emerging here, which we really need to face up to. Number one, it is impossible for every teacher to know answer to all questions that children can ask in the classroom.
Sure.
Okay? So, as a value to say that teachers should give answer to questions of children, should be able to give answers to all questions of children. All why. I mean, why questions are the most difficult to answer. And we need to appreciate that science does not move to the why question at the first stroke. We first need to understand how, what is happening. How is it happening before we come to the why questions. And the teachers need to admit this to children right from the beginning, that there will be questions to which I as a person don't know answers. That does not reduce my status as a teacher, because that is a deep psychological problem that we've created for our teachers, that if a teacher stands up in the class and says, I don't know the answer to this question, her respect or her status will go down. Okay? So this is one issue that we need to get over with the teachers also in a very balanced way. to be able to say that I don't know the answer. Secondly, I think we also need to enunciate this value that to be knowledgeable is not a measure of how many questions you can answer. To be knowledgeable is a measure of how much you know that you don't know, and to what depth you don't know. I just want to complete this, because you see, in science at least, we have had to be quite strong in asserting this, that at which level, what sort of questions can one approach, not answer. In fact, we've been saying that as a pedagogical exercise, to take a position that you ask a question and I'll answer all your questions is not only a false position, pedagogically, it's a undesirable position. And I'll just try and explain why it's an undesirable position. That our major pedagogical goal is to train children in finding answers to the questions, in pursuing their curiosities. And the belief that by answering, giving complete answers, finished answers to their questions and telling them that yes, now this is the complete answer, we are actually killing their curiosity. And we are not training them in the process of pursuing their curiosity. We think that by giving correct answers, we are satisfying them. I think that is not.
Yes, I agree with you 200%. Please, you are the teacher. I am an 8-year-old student. I come and ask you, sir, how does the sun generate heat? Please tell me what you do. That's all I am asking.
I'll first of all say that I don't know the answer to this question well enough to answer to tell you.
Even though you know. Even though you know.
No, I don't know. I personally can tell you that I don't know.
How is asking
It's not being said that
I don't know how to explain to an 8-year-old child
this is the
how
question.
the energy of sun
Yeah, that's the question.
Yes,
that's what I'm saying.
Knowing the answer
So, but
is a different thing from not knowing how to explain to an 8-year-old. They are two different things.
But as a teacher, I can't say I don't know the answer.
Yeah.
I know the answer. The problem
If I don't know, I should say I don't know. But if I know, why should I say I don't know?
No, Kamal is not saying that we should compromise the depth, we should compromise the... Actually, he is saying that suppose at the 8th standard, we are going to teach one concept, so we need to make a standard that how much the depth we are dealing with in this particular standard and do it. He is not saying that you should compromise the whole intricacy.
No, Kuldeep, I have a problem. I have a problem with this. Presently, I am just like, coming up with this in the head. Who decides how much a child needs?
can understand.
I mean, I can say with all the research going on and things like that, because we are not going to never end this research, and as the evolving mind or the human mind and whatever it is, who decides what is right and wrong for the child? We may endlessly debate on this, but the child is still asking me, okay? And as I am a teacher, as he says, I do understand the philosophy behind it. I do understand, I cannot explain to him or her everything. Nor I am taking a stance that I know the answer as she says. Even though I have done some MSc or PhD, I might still go wrong with the current research showing that my paper is wrong. I am taking okay. I'm in that position. But a child is burning with a curiosity. I'm assuming it is with a curiosity the child is asking me a question. Okay, the real problem, I'm not saying immediately give me an answer. The teachers are faced with such a problem, and that is the question. We are not trying to ask a question as to if a child is asking this is what you have to answer. Nay. There are so many questions are being raised, and who is to debate on how much you have to say. And now Manish is saying mechanics is introduced in 11th, and therefore calculus should be introduced in 11th. Okay, and who is he to say it has to be introduced in 11th? I'm just saying who, he means not he.
But who is stopping you to pursue the curiosity of children?
Exactly, exactly. So when a 6-year-old is actually asking me a question, why does the sun is burning there and why can't I explain, actually sit with the child and go through the process.
Kamal is saying that you do it, you explain it, but don't compromise the in-depth, don't compromise the intricacies of the subject.
I'm asking you, please show me how without compromising I can explain to an 8-year-old nuclear fusion. Please show me.
I can't.
Where does the child go?
That to the child.
Then where does the child should go? He's having the curiosity to know, and obviously, seeing the level of the child, this concept is difficult to explain.
No, please understand. You see, the child asks a question. The only alternative before me is that I have to answer that question. I am questioning that. What will I do with the child who is asking this question? I have many alternatives. A 6-year-old child, if I just say that there is a very hot fire burning in the sun, and that is what gives heat from the sun, a 6-year-old child can go in many directions. See, my answer is not wrong. Okay? I am saying it in a language in which that child can possibly understand. But there will be a child who will say, why is that fire burning there? Is there so much of wood there that is burning, a coal, or what is burning there? Okay. Now, the question is reaching into a stage where it's impossible for you to explain it to a child. And it's taken human civilization years and years and generations to arrive at some answer. And we don't know whether that answer is the final answer.
But yes,
that is
at
nature of
that
science.
stage.
Okay. So, I can, knowing the child whom I am interacting with, try and give an answer, but at the same time admitting that this is not the only answer, this is not the final answer, there will be further nuances to it.
But yes,
and to know more about it, well, let us go and look at other sources, or you have to.
But when you say that there is a fire burning in the sun over there, so you give a trigger to the curiosity. Then the child is asking the next question, that what is it that is burning? Now you can't say that I don't know.
I can.
You will have to take him to some other explanation, and maybe you will have to sustain that curiosity and give some explanation, and you will have to encourage that child to explore himself, to wait and to have this curiosity. That is very complex.
But because what I'm trying to say you is that you see, you are cornering me because you think I have studied physics and I know what is nuclear fusion. Okay?
That's why I know it, because I couldn't find out where anything is like. And you think I can't do this?